Ever tired of typing those mile-long iterator types? What if compiler just figure it out for you? That's exactly what auto does, and it's smarter than you think. Welcome to episode 2 of our modern C++ 101 series. Stick to the end of the video to find out what is auto and how it can be used, including more complex scenarios such as storing a lambda into a variable, auto parameters, forwarding references, and more. The auto keyword was introduced in C++ 11. The type of the variable is deduced by the compiler from the initializing expression, and it works in a similar way as templates type deduction. When dealing with pointers, we can explicitly add an asterisk for better readability and to make sure that the assigned type is indeed a pointer. One of the most important things about auto is that it drops references, const qualifiers, and volatile qualifiers. In this example, we are making a copy of b. To create a reference, we need to add the ampersand symbol. If the variable is const, we also need to add the const keyword. Probably the most notorious use of auto is when using iterators. I'm sure you will never write the full type again once you know about auto. By the way, if you like these videos, hit like and subscribe. It really helps the channel grow. When using braced initializers, the type of the auto variable is different based on the following syntax. In the first two examples, the type of the variable is an initializer list, while in the third example, the type of the variable is int. The same as templates, by using auto we can create a forwarding reference, or also known as universal reference. Auto ampersand ampersand can bind both to an a value or an r value reference. This enables perfect forwarding, but that is a topic for another video. Now let's talk about lambdas. The only way to store a lambda into a variable is by using auto, because the type of the lambda is only known by the compiler. As of C++ 14, we can use auto in the parameter list, enabling polymorphic or template-like lambdas. Another cool feature is that starting from C++ 11, functions can have trailing return types. In C++ 11 we need to explicitly write the type on the right, while starting from C++ 14 the type can be omitted. The decltype autotype specifier also deduces a type like auto, but it preserves references and const qualifiers. More on decltype keyword in another video. That's a wrap for today. Smash that like button, drop a comment auto for life, and hit subscribe so you don't miss the next video.